Hello and welcome to Share Science. Today we are going to explore crystals and one fun way you can discover how they form with a tasty experiment. Crystals can be found in all sorts of places, but did you know you can make your own? Today we're going to use sugar to explore the conditions for making crystals, and we'll end up making our own geode. Our experiments today are going to focus on how crystals form through the process of nucleation and growth. If you want to follow along, you're going to need a few things. To explore nucleation, we're going to recreate the famous cola and Mentos experiment, so you'll need a bottle of cola and a few Mentos candies. For the next experiment, we're going to need sugar, fondant, which is a sugar dough bakers use to ice cakes. If you don't know where to get some, we've added an Amazon store link to the notes below. Food coloring, to turn the fondant into something that resembles a rock, and for whatever color you'd like to make your geode. Cooking spray to make our geode easier to remove from the mold, and a cooktop to melt our sugar solution. Remember to seek adult supervision if needed. Once we have our equipment, we're going to learn 3 key things to better understand how crystals form. First, we're going to learn what a crystal is and under what conditions they form. Next, we're going to discover the role of nucleation and growth on crystal formation. And finally, we're going to explore where we can find more crystals, which are actually all around us. We should start by defining what a crystal is. When you think of crystals, you may think of what you see here, which are crystal gemstones. But a crystal is any solid material that is highly ordered, whose surface represents that order. This is why the sides of a crystal are faceted, meaning they have many sides that can sparkle when they catch light. Most crystals form underground, under intense heat and pressure. But we can explore how they start through a popular experiment involving cola and Mentos. You may have seen this experiment before, since lots of people have tried it. This one was done by the slow-mo guys, who like to show their experiments in slow motion. When the candy is put into the cola, we see a violent reaction that creates a large number of bubbles that shoot through the bottle opening like a geyser. Let's watch it a few more times. Now let's take some time to look at how this experiment works. Every bottle of cola you can buy is actually an example of a supersaturated solution. A supersaturated solution is one in which an overconcentration of one material is put into another. In this case, carbon dioxide into a sweet drink. The solution is stable until we release the pressure by opening the cap, which causes the bubbles to fall out of solution wherever they can, usually on the sides of the container or on anything that's thrown in, like a Mentos candy. What's critical for nucleating the most bubbles is a rough surface. While the Mentos candy looks smooth, the reason it's used in this experiment is it actually has a really rough surface when you get close enough. If we take a single candy and zoom in, the surface actually looks more like this, really rough and cratered, like Swiss cheese. When we put the Mentos into the cola, this rough surface is perfect for nucleating the carbon dioxide bubbles that are supersaturated. When the bubbles form, since they're lighter than the liquid, they rise to the surface. But there are so many of them, all the bubbles rise at once, pushing everything above them up as well. This is what creates the huge geyser of soda that we saw in the video. Now that we understand how nucleation works, let's look into how we can use it to make crystals of our very own. First, we're going to roll out a package of fondant into a thick layer that's going to look like the outside of a geode, which is a kind of crystal that forms in nature. The fondant will serve as the nucleation layer of our sugar crystals. Next, we're going to line a small bowl with aluminum and cooking spray to act as a mold for our geode and lay our fondant inside. Once our mold is ready, we can dissolve 3 cups of sugar into 1 cup of water. This is the supersaturated solution that will form our crystals. When it's dissolved, we'll add whatever color of food dye we want our crystals to look like. Finally, we pour our solution into the fondant mold and cover for at least 48 hours to give our crystals time to grow. Here's a demonstration of our process. We start by melting our sugar and then adding red and blue food coloring that will give us deep purple crystals. We set that aside to cool while we roll out our fondant. For our experiment, we started by rolling out a layer of white fondant and then mixing brown fondant into another layer of white to create a second layer that will resemble the outside surface of a real geode. We rub a little water on the brown layer and then place the white layer on top to help it stick. Once our fondant is ready, we fold 2 pieces of foil together and put a small bowl on top that we layer with another piece of foil, spraying with oil to stop the fondant from sticking. After we press our fondant into the mold, we can cut off the excess and pour our solution in, covering with the outer foil layer and leaving for at least 2 days for our crystals to form. After 2 days, we pour off the excess liquid and cut any remaining excess to admire our very own sugar geode. Let's take a look at how this works. In this experiment, the fondant surface is just like the Mentos, representing a surface full of tiny sugar crystals that act as seed crystals for our geode. When we add our supersaturated sugar solution, excess sugar bonds with the seed crystals in the fondant and grows into larger sugar crystals all across the surface. While our process only takes a day or two, it's very similar to the way that real geodes form in nature, where mineral-rich water gets trapped inside rock and crystallizes into beautiful patterns over thousands of years. Now that we know how crystals form, let's apply our learnings and see if we can think of any crystals that we come across in our everyday life. We've already covered geodes, an example of which is shown here. But are there any other places you might see crystals every day? Remember, crystals are characterized by faceted surfaces that have very characteristic shapes. One example we can find in winter are ice crystals that can sometimes form very cool patterns on icy windows. Another example that we might find in the pantry is honey. Since honey is another example of a supersaturated solution, over time, honey can crystallize to form beautiful shapes in the bottom of the jar. Our final example is one that you probably come across every day and is likely on your kitchen table. It's salt. Salt crystallizes into small squares that we can sprinkle onto our food to help it taste better. We can find crystals in so many places, sometimes in some really tasty ones. To summarize, we learned how crystals form through a process of nucleation and growth from supersaturated solutions. Some crystals need time to grow. We can grow sugar crystals in a couple of days, but mineral crystals can take thousands or even millions of years to form and grow to amazing sizes, up to 60 feet long. In addition to crystals we can dig from the earth, we can also find crystals all around us in our everyday life, some of which are in your own kitchen, like crystallized honey and salt. We hope you liked today's video. Please like and subscribe to get more content just like this.